Okay, exercise 1b involves polynomials. And if you read on page 5 there, a polynomial in x is an expression that consists of terms which have non-negative integer powers of x only. And here we have the definition, standard definition of a polynomial. P of x equals all of that. I won't read it all out, but as you can see, what happens that's the highest power, sometimes known as the degree of the polynomial. And then the next term, okay, you've got the a lower power there, n minus 1, and the powers keep on going down. And the last three, you've got an x squared term, an x term, and what's called a constant there, or a number by itself. Now, of course, you don't have to have all of those terms. For example, you might not have that second last term, okay? But that's the general form of a polynomial, and that's there at the bottom of page 5 on the section on polynomials. So that's the definition of a polynomial. Important things to remember here, that n, that as I pointed out there, that's the highest power or degree. And these numbers, an minus 1, etc., they're called the coefficients. So, for example, if we had 3x to the power of 7 plus 4x squared, that's a little polynomial in itself. It has a degree of 7, that's the highest power of x. Coefficients there are 3 and 4. You've probably met the term powers and degree and coefficients before, so they'll probably be fairly familiar to you. So that's the definition of a polynomial. For an expression to be a polynomial, only non-negative integer powers must be present. Okay, non-negative integer powers. Okay, non-negative means they must be positive, or they can also be 0. Okay. Let's have a look at some expressions and see whether they're polynomials or not. Let's look at this first one. In fact, what we might do is just take that little definition there, and I'm going to copy it across to the next page, and we'll put it in there so we can look at it again. And here we go. Just get rid of this little bit here. There we go. So let's look at our definition. For it to be a polynomial, only non-negative integer powers must be present. So if we look at all the powers here, we've got power of 6, power of 4, power of 3, and power of 1. Remember, an x by itself is always a power of 1. They are non-negative integer powers, so we can say yes, that is a polynomial. Next one, if we put in our definition again, for an expression to be a polynomial, only non-negative integer powers must be present. And now here's the key word this time, integer. Okay, integer, remember the counting numbers, 1, 2, 3, 4, etc. Right, we haven't got any negative powers here, but we certainly do have 9 on 2. Now we can have 5 because 5's there by itself, but remember that 5 could be 5x, or negative 5, could be negative 5x to the power of 0. So that's where our non-negative comes in, because 0 is a non-negative number. So the negative 5 was no problem. That didn't stop it from being a polynomial. What stopped it from being a polynomial was the fraction 9 on 2, because they need to be integers or whole numbers. Next one. A couple of reasons this one gets knocked out from being a polynomial. First of all, it's got that 3xy expression there. It's not a power of x only, there's a y involved, so the y knocks it out from being a polynomial. And also this guy over here, that x, the square root of x. Now, the square root of x is also x to the power of half. You probably remember that from year 9 and 10. So, 2 reasons. That's a non-integer, okay, so it's a fraction, and you've got two pronumerals there, x and y. So that is not a polynomial. This one here, 8 plus 2x minus 3x squared plus 9x cubed minus x to the power of 4. Fine there, there's no negative integers, they're all positive or 0, so that is fine, that's a polynomial. Let's get this one here, get 3x squared minus 2. Now you might remember that an x squared in the denominator there, if I put that up into the numerator position, that becomes x to the negative 2. So I can transform that expression from 3x squared minus 2 over x squared to 3x squared minus 2x to the power of negative 2, which means it's not a polynomial because the integers must be non-negative, and that's a negative 2. So that one is not a polynomial. Okay, so we've just defined polynomials, and we've identified which ones are and which ones aren't from a series of examples. Now we've got 3 polynomials here, and they certainly are polynomials, as according to our previous definition. We're now going to do some addition and subtraction of these guys. So there's p of x, q of x, and r of x. There they are again, and we're going to add p of x plus q of x. Alright, so let's look at that. We've got p of x is 6 minus 2x plus 3x plus x. We're going to add to that plus x. We're going to add to that q of x, which is x to the power of 5 minus 2x to the power of 4 plus x squared. Okay, so this is p of x plus q of x. So that's going to equal, collecting like terms, and what we might do is put them in order of powers. So we'll start with our x to the power of 5. It's the only one of its type there, x to the power of 5. Then x to the power of 4s, we've got negative 2x to the power of 4. We haven't got any x to the power of 3s, but we've got x squareds there, so it's plus x squared. We've got a few x's. We've got 3x plus x is 4x, take 2x is negative 2x plus 6. So there we are, that's p of x plus q of x. Now what about p of x minus r of x? Right, so let's write out here p of x first of all, and we get 6 minus 2x plus 3x plus x. Now we're going to subtract r of x. Now I want you to remember this all year when you're subtracting an expression such as this. I'd like you to get into the habit of putting it into brackets, because what that can do is force you into subtracting both terms. If you're rushing and you leave the brackets out, you can subtract the first term but forget to subtract the second one. So it's worth that extra step, that extra line, because as I say, if you're rushing or not concentrating, this sort of thing can happen. Okay, so take away minus x squared. Now a negative of a negative is plus 4. Alright, collecting like terms, we've got negative x squared. 3x plus x minus 2x is plus 2x. 6 plus 4 is plus 10. Okay, so there's some addition of polynomials. Now let's look at evaluating polynomials. So we've got this polynomial here. We've got p of x equals 2x to the power of 4 minus x cubed plus 5x squared minus 6x plus 4. And what we need to do here is find two things. We're going to find p of 1, okay, and also p of negative 2. Alright, we're doing this without the calculator at the moment, of course. So if that's p of x, to find p of 1, we simply put in, wherever we see an x, we put in the value 1. Okay, so to the power of 4 minus 1 to the power of 3 plus 5 times 1 squared minus 6 times 1 plus 4. So compare the two expressions there. I've placed in 1 where there formerly was an x. So equals 1 to the power of 4 is 1, so we get 2 ones are 2, minus 1 cubed is 1, minus 1, plus 5 times 1 squared. 1 squared is 1 times 5 is 5. Negative 6 times 1 is negative 6 plus 4. We add all that together. Okay, we get 9, 11 for the positives there. Minus 1 minus 6. 11 minus 7 equals 4. Just pointing out here with this one, and I might just change pen colour for a moment, just so it stands out a bit more. Worth noting with this one, got to be careful this year because negative of 1 cubed, okay, is negative 1, but actually that's not a good example. I might just might use another example. Just be careful because negative of 1, say it was a power, or say it was squared. Let's look at squared. Okay, and negative 1 squared are two different things. That one is the negative of 1 squared, which is negative 1. This one is negative 1 squared, which is negative 1 times negative 1 is positive 1. So just be careful with the distinction between those two. Right, back to the black pen. We've still got to do the second one now, which is p to the negative 2 equals 2 times negative 2 to the power of 4 minus negative 2 cubed plus 5 times negative 2 squared minus 6 times negative 2 plus 4. Just squeeze it in there. Evaluate everything here. Right, negative 2 to the power of 4. Negative 2 times negative 2 times negative 2 times negative 2. That's going to give us 16. 2 times 16 is 32. Negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8. And we've got the negative of negative 8. So that's going to be a positive 8 there. Negative 2 squared is 4. 5 fours are 20. Negative 6 times negative 2. Remember, this is multiplication, not adding. That's going to be positive 12. And then we've got plus 4 as well. So positives across the board there. If we add those together, we get a total of 76. Okay, the last question I want to do in this recording for polynomials is a slightly more complex one, and this sort of approaches as something we might see in an exam at some stage. So if p of x, the polynomial, equals ax to the power of 5 plus x to the power of 4 minus 3x cubed plus bx take 5, that's our polynomial. We know that p of negative 1 equals 5 and p of 2 equals negative 60. Find the values of a and b. So you want to remember in the course this year that whenever we've got to find two variables, okay, either via a calculator or not, we probably have to find at some stage the answers using simultaneous equations, and that's certainly the case in this question. But first things first, let's start off by substituting in negative 1 into this polynomial and see what we get. So let's first of all work out p of negative 1, and that's going to be a times negative 1 to the power of 5. So I'm just substituting in negative 1 for x, like I did in the previous examples. So here we go, negative 1 cubed. Let's try and get that back again, that's it. Negative 1 cubed plus b times negative 1 minus 5. Tidying that up, any negative number raised to an odd power will always be a negative answer. So this is going to be negative 1. A negative 1 to the power of 5 is negative 1. A times negative 1 is negative a. We've got negative 1 to the power of 4, that's going to be positive 1. So any negative number raised to a even numbered power will give us positive there. So we get positive 1. Negative 1 cubed is negative 1 times negative 3 is plus 3. B times negative 1 is negative b. And we've got minus 5 there. Now, if we tidy that up, we get negative a minus b and 1 plus 3 is 4. Take 5. And 1 plus 3 take 5 is negative 1. Now, we know, we're told in our background information that p of negative 1 equals 5. So I can now equate that, I'll just move over to here for a moment, I can now equate that to 5. Because I've worked out p of negative 1, there it is, that expression there. I'm now going to equate that to 5. So 5 equals negative a minus b minus 1. Now, good thing here, negatives, I try and get rid of them as much as I can. So, if I look at this and, the change sides thing that we've used for quite a few years now in our equations, if I take the negative a and the negative b to the left-hand side here, they become a plus b equals, and if I take the negative, the positive 5 to the other side, just had to pause that for a moment because I realised I've made an error here in the question. That should be negative 5 up there, so in the background information, so I just fixed it up. P of negative 1 equals negative 5 up here. So just sure that's clear, equals negative 5. So, sorry about that. So down here, that's negative 5 there. So what we've got is a plus b. Take the negative 5 across, we get negative 1 plus 5 is 4. So a plus b equals 4, like so. So that's our first equation to get to. So now go on and find another equation. So remember, there's our question that we started with just there. And now we know that p of 2 equals negative 65. So let's find p of 2 equals, so we're substituting x for 2. We get a times 2 to the power of 5 plus 2 to the power of 4 minus 3 times 2 cubed plus b times 2, take 5. Expanding that, we get 32a plus 16 minus 24 plus 2b, take 5. Tidying that up, we get 32a plus 16 minus 24 is negative 8. Take another 5 is negative 13 plus 2b. Now we know that expression there, okay, according to our background information, that expression there, that equals negative 65. So tidying that up, we get 32a plus 2b equals negative 65 plus 13. Negative 13 becomes a positive if we take it to the right hand side, and we get negative 52. There we go. So we've got our two equations. Going back to the previous page, for a moment we saw that we had a plus b equals 4, so we'll put that there as well. So we've got both equations there. A plus b equals 4. Alright, so we've got equation 1 and equation 2. And equation 2 is there. Alrighty, let's look at those two equations and we'll go ahead now and solve them simultaneously. Alrighty, 32a plus 2b equals negative 52a plus b equals 4. Now, what I'm going to use here is a method called substitution. And it's often a good method to use when you've got this sort of situation here, and a plus b equals 4, because I can transform that equation there and make it b equals 4 take a. Okay, and this method's called substitution. Equation 1, we now substitute 2 into 1. So we get 32a and plus 2b. Now we know what b is. b equals 4 minus a. So we can put in 2 outside of 4 minus a equals negative 52. Expand the brackets, 32a plus 8 minus 2a equals negative 52. Okay, so tidying up the left-hand side, we get 32a, take 2a, we get 30a plus 8 equals negative 52. Nearly there. So next page. There it is. Take the 8 across, we get 30a equals negative 52, take 8. 30a equals negative 60. A equals negative 2. Alright. Once we've found a equals negative 2, and we know that b equals 4 minus a, b therefore equals 4 take negative 2, b equals 6. So our answers, a equals negative 2, b equals 6. So there we go, there's some introduction to polynomial. Please now have a go at exercise 1b. We'll continue that in class next time.